Some of you might be tired of doing some of your university math. So I thought, hey, why not create a video you can take a break and do some grade 7 math? So here's a question from our grade 7 math contest. A school trip offers 3 activities, hiking, canoeing, and swimming. And attendance records show that 10 of the students did all 3 activities. 50% did at least hiking and canoeing. 60% did at least hiking and swimming. And K% did at least canoeing and swimming. No students did less than 2 activities. Given that K here is an integer, sum up all possible values of K. Pause the video, take a few minutes, and try and solve this problem. No, really, stop, pause, take a few minutes, and try and solve this problem. All right, I hope you have an answer. And now you can compare your answer with mine. As with most problems, I'm sure there's more than one way of solving this problem. So if you have a different solution, feel free to comment below with your solution. I started by letting t be the total number of students. Then I thought about how could I calculate this number t? Well, I could take 0.5 of t, which is the number of students who did hiking and canoeing, then plus 0.6t, which is the number of students who did hiking and swimming, then plus k over 100t, which is the number of students who did canoeing and swimming. And now these 3 groups of students will cover all of the students because no students did less than 2 activities. The problem is that these numbers here actually double count some students. And in fact, any student who did all 3 activities will be counted in each of these 3 things. And so we'll have triply counted them. We only want to count them once. So we need to subtract out 2 times the number of students who did all of the activities. So that's minus 20. And that will give us our total number of students. Let's do a little bit of a simplification here. I get 1.1t minus t. So I have 0.1t plus k over 100t is going to equal to 20. I could simplify this as being t of k plus 10 over 100 equaling to 20. And solving this for t will give us that it's 2,000 divided by k plus 10. I know that t is an integer, so that means that k plus 10 has to be a divisor of 2,000. But we actually know a couple more things here. We actually know that 0.5t has to be an integer, which means that 1/2 t is an integer. So t has to be divisible by 2. And 60%, which is 3/5, 3/5 t also has to be an integer. So t has to be divisible by 5. And if it's divisible by 2 and divisible by 5, that means it has to be divisible by 10. So we know that t has to be divisible by 10. So I know that t has to be then 10 times some, I'll use small t. So I'm going to get that 10t is 2,000 over k plus 10, which I could simplify then as t, little t, is equal to 200 over k plus 10, where I know that this little t here is an integer. So that means k plus 10 has to be a divisor of 200. Now we also know that k over 100 times t has to be an integer, and I'll come back to that in the end. So now I essentially need to find all integers k, such that k plus 10 is a divisor of 200. And I've written down the prime factorization of 200 up here. That will be helpful. We also need to make sure that k has to be greater than or equal to 0. So that means that k plus 10 has to be greater than or equal to 10. We also know that k has to be less than or equal to 100. So that means that k plus 10 has to be less than or equal to 110. So essentially, we're looking for divisors of 200 that are greater than or equal to 10 or less than or equal to 110. Well, we know that any divisor of 200 must be of the form 2 to some exponent times 5 to some exponent, where the exponent on the 2 is either 0, 1, 2, or 3, and the exponent on 5 is either 0, 1, or 2. Well, if the exponent on 5 is 0, then the most that this could be then is 8, because we get 2 cubed, which is not going to be big enough. So the exponent on 5 can't be 0. It has to either be 1 or 2. So let's consider 5 to the exponent 1. 2 will have to be then to the exponent at least 1. So one of the possibilities is k plus 10 is 10. Then I could also have 20 when I have 2 squared, and 40 when I have 2 cubed. If I have 5 to the exponent 2, I could have 25 times 2 to the 0. I could have 25 times 2. I could have 25 times 4. But if I do 25 times 8, I'm already too big. So these are all the possibilities for k plus 10, which means that k is either 0, 10, 30, 15, 40, or 90. Now, I did say we would come back and check for these values of k, is it true that this will provide us with an integer? Well, we know that t is a multiple of 10. So for the situation of 0, 10, 30, 40, and 90, okay, we know that k over 100 times t will be an integer. What happens though when k is 15? Is this going to be a valid answer? Well, let's just check. If k is 15, then k plus 10 is 25. 200 divided by 25 is 8. So little t is 8, which means that big T is 80. So if we check, 15% of 80 is 12. Yes, that is an integer. So this is a valid solution. So the possible values for k are 0, 10, 30, 15, 40, and 90, which means the total of all possible k values is 185. Is that the answer you got? Feel free to comment down below how you got the solution. I hope this was a nice break from your university math, but now it's time to get back to your homework, because as I always say, keep on practicing.